Hi, everyone. Welcome to our next math lesson. Today we are in Chapter 8, and we're looking at Lesson 2, the greatest common factor, or GCF. Students will be able to determine the common factors and the greatest common factor of a set of numbers. All right, so I want to go over a little vocabulary first. I want to go over what the word factor means. So when we multiply numbers together, for example, 2 times 3, those numbers that we are multiplying are called factors. And what you get after multiplying factors, that's the product. So we have factors are what we are multiplying, and then the product is what you get. So when we are doing this skill of finding the greatest common factor, we want to know when you have two numbers or more, so a set of numbers, we'll say we have two numbers, what's the greatest number that those numbers can be divided by? In other words, what is the greatest number that is a factor of both numbers? So let's start off by just playing around with factors. I'm going to take the number 12, and I want to think of all of the whole numbers that I can multiply to make 12. So being a math teacher, I like to do this in an organized way. So I like to think of all of the whole numbers that I can multiply to get 12, and I'm going to start with 1, because 1 times the number will always give you what you want. So I know that 1 times 12 equals 12. In other words, 1 and 12 are factors of 12. What else can I multiply to get 12? Let me try 2. Yep, 2, 4, 6, 8, 10, 12. 2 6 times gives me 12. 2 and 6 are factors of 12. Let me try 3. 3, 6, 9, 12. 3 times 4 gives me 12. Now, I'm not going to keep trying because when I count 1, 2, 3, 4 is right here. So that tells me that everything else is done because I have a 4 on this column. Now, you could keep thinking 5, 6 is already here, 7, 8, 9, 10, 11. None of those numbers can be multiplied by another whole to get you 12. So these are the factors of 12. 1, 2, 3, 4, 6, and 12. Now, if I'm finding common factors or the greatest common factor, I need another number. So let's do 15. So I'm going to list and figure out factors of 15. I always start with 1 times that number because it will always work. So 1 and 15 are factors of 15. Let's keep going. Let's try 2. If I count by 2s, I don't get 15. So 2 is not a factor of 15. Let's try 3. 3, 6, 9, 12, 15. Okay. If I have 3 5 times, I get 15. So the only number left to try would be 4. 4, 8, 12, 16. No, 4 doesn't work. 5 is here, so we're finished. All right, so I have two numbers. I've listed some factors of those numbers. Well, what's in common? What are some common numbers or common factors that we listed for 12 and 15? Well, they both have a 1, and guess what? Every whole number has 1 as a factor, so that will always be a common factor. What else do they have in common? Oh, I see they both have a 3. Anything else? That's it. So we have 2 common factors for 12 and 15. We have 1 and 3. That means 12 and 15 can both evenly be divided by 1 and 3. So now, if I look at those common factors, Which one's greater? 3, of course. So 3 is the greatest common factor, or GCF, of 12 and 15. And that's how we find the GCF. Now there's another method to doing this, and it's using prime factorization, which we've done before. Okay, we've used prime factorization in, I think it was chapter 2. So we're going to do the same problem, but I'm showing you a different method. So we're still finding the greatest common factor of 12 and 15, just a different method. And this method really works better for greater numbers or numbers you're not very familiar with. 12 and 15 are not too crazy. We work with them quite often. They're in our times tables. A lot of us can think about 12 and 15 pretty easily. But I'm going to show you this method anyway. So what I want to do to find the greatest common factor of 12 and 15 is I want to find their prime factorizations. What's that? Prime factorization is when we take a number, we break it down so that we are multiplying all of the prime numbers. What are prime numbers? 2, 3, 5, 7, 11. Numbers that can only be divided by 1 in themselves. Okay, those are prime, in case you forgot. So what makes 12? What can we multiply to make 12? Well, one thing we can do is 2 times 6. You could have picked 3 times 4 as well. Remember that when we come to a prime number, we stop and circle that number. And if we can't circle it, we break it down. What multiplies to make 6? 2 times 3. 2 and 3 are both prime, so we circle them. So what is the prime factorization of 12? 2 times another 2 times 3. So let's find the prime factorization of 15. What multiplies to make 15? 3 times 5. And they're both prime. That's a short one. So for 15, we have 3 times 5. All right, so how do we find the prime factorization from here? What do we do? Well, we want to look at all of the primes that are in common. So what's in common in our list of primes? What does 12 have that 15 also has? Not 2, because there are no 2's over here for the prime factorization of 15. I do see that they both have 3, but not 5. So what is the number I circled? I circled a 3, and that tells me that the GCF equals 3. All right, because that is the number that we circled that's in common. So that is another method on finding the greatest common factor. Let's do one more example. Let's find the prime factor, or the greatest common factor of 30 and 72. So larger numbers, I'm going to use prime factorization to work this out. What multiplies to make 30? The first thing that comes to my mind is 3 times 10. Maybe you were thinking of 2 times 15 or 5 times 6. They would have worked. 3 is prime. What multiplies to make 10? 2 times 5, and they are prime. So the prime factorization of 30 equals 2 times 3 times 5. All right, 72 is made up of 8 times 9. 8 can be broken down to 2 times 4. And 4 can be broken down to 2 times 2. 9 is not prime. It's made up of 3 times 3. So 72 is made up of 2 times 2 times 2 times 3 times 3. Now, I did that quickly, okay? If you are really struggling with doing these factor trees, then that's something that you want to go back and watch a video on or practice again, or maybe not do this method. So now that I have the prime factorization for both of my numbers, I want to find the primes in common. Now, what does 30 have listed that 72 also has? Well, 30 and 72, they both have a 2. Notice I only write it one time. I'm just saying that they have a 2 in common. Well, they don't have any more 2s in common because 30 doesn't have any more 2s. They have a 3 in common. They don't have any other 3s in common, and 72 never had a 5. So they have 2 primes in common. They both have a 2. They both have a 3. So to find the GCF, I multiply those common primes. And 2 times 3 equals 6. So the GCF of 30 and 72 equals 6. They can both be divided evenly by 6, and that's the greatest number that I can evenly divide them by. All right, so we're going to spend another day on GCF. This is a 2-day lesson, and if you need more support, please let me know. You can check out previous videos, or you can rewatch this video on my YouTube channel, and have a great rest of your day. I'll see you soon. Bye.